this video, we're going to demo doing inference for one proportion. The data come from the General Social Survey, which asks, two scientists want to know if a certain drug is effective against high blood pressure. The first scientist wants to give the drug to 1,000 people with high blood pressure and see how many of them experience lower blood pressure levels. The second scientist wants to give the drug to 500 people with high blood pressure and not give the drug to another 500 people with high blood pressure and see how many in both groups experience lower blood pressure levels. Which is the better way to test this drug? Either all 1,000 patients get the drug, or 500 patients get the drug and 500 don't. The better way to test this drug actually is that 500 patients get the drug and 500 don't, because this allows us to have a control group, which is important if we want to do an experiment. So using these data, there are 670 responses to this question in the 2010 General Social Survey. We want to answer these two research questions. Estimate the true proportion of Americans who have a good intuition about experimental design, in other words, who answered this question correctly by choosing only 500 get the drug, and to also answer the question, is this proportion greater than 80%? 80% here is an arbitrary number that we're just using in order to demonstrate doing a hypothesis test. So first we're going to do a confidence interval for our estimation, and then we're also going to test these data against a null value of 80%. Let's start by loading our data set. Click on the upload button, find the data set on my computer. It's a CSV file. Hit OK so that I can see it in my files pane. Then I need to import this data set into my workspace so that it's usable for my analysis. It's a comma-separated file. That's what CSV stands for, comma-separated values. And there is indeed a header row. The first row is the name of the variable as opposed to actual data. So once I specify those, I hit import, and I can see that there are 670 observations in my data set. Each row or each case corresponds to a person who answered this question on the General Social Survey. Some people answered incorrectly, choosing all 1,000 get the drug, and others answered correctly, saying only 500 get the drug. So this is a categorical variable with two levels, a success and a failure, and we want to estimate the proportion of successes for the entire American population, assuming that these 670 people comprise a representative sample from the American population. How can we do this? Well, we're going to use our inference function, so let's make sure that that's loaded in our workspace and it appears over here. I type the name of my function, I give it my input. My data come from the file called GSS-EXPDES, that's GSS experimental design, you can call it whatever you like, and the name of the variable, separated by a $sign, is response. I'm estimating a proportion, since this is a categorical variable. I want to do a confidence interval first of all. We'll get to the hypothesis test next. And since I'm constructing a confidence interval for the true proportion of Americans who have a good intuition, I want to specify what level of this categorical variable I want to call a success. There were two levels, remember, either that all 1,000 get the drug or that only 500 get the drug. So in this case, the success is going to be only 500 get drug. Remember, success doesn't have to be positive. It just happens to be what we want to estimate. In this case, it's the correct answer. If the question was phrased, estimate the true proportion of Americans who don't have a good intuition about experimental design, we would specify the other level as our success in our function. And lastly, let's start with a theoretical approach. The output here shows me that I'm doing inference on a single proportion and that my success is the level only 500 get the drug. The summary statistics are that I have 670 observations and 85% of them, so my p-hat, the proportion of success in my sample, is 0.8522. About 85% of the respondents answered this question correctly. Since I'm using a theoretical method, I want to make sure that I check my conditions, and for a confidence interval, that would be the number of successes and failures. The observed ones should both be greater than 10, and in this case we can see that they are. The function calculates the standard error for me, And using my point estimate, a critical value of, in this case, 1.96, since we're constructing a confidence interval using a z star for proportions. So my p hat plus or minus 1.96 times the standard error yields the following confidence interval, which I would interpret as I am 95% confident that between roughly 83% to 88% of Americans have a good intuition about experimental design. I can also construct this confidence interval using a simulation approach. And remember, when we're doing a confidence interval using a simulation approach, we're doing bootstrapping. So think about it as I have a bag filled with 670 chips. 571 of them have the correct answer on them. Those represent the people who gave the correct answer. Only 500 get the drug, and the remainder 99 of them represent the failures. I sample from this bag these chips with replacement, and I create samples of size 670. These are my bootstrap samples, and for each one of these simulated bootstrap samples, I calculate a bootstrap statistic, in this case, the simulated sample proportion. So let's give our a second to do that for us. We can see that in our bootstrap distribution, the center of the data is basically, the center of the bootstrap distribution is basically going to be at the observed p hat, and then once we calculate our bootstrap distribution, we chop off roughly 2.5% of the distribution from both ends to construct a 95% bootstrap interval that is very similar to what we calculated earlier. We can also answer the second part of the research question, is this proportion greater than 80%, using a hypothesis test using either a simulation or a theoretical method. Let's start with a simulation. All I need to do is change from type CI to HT. And since I'm doing a hypothesis test, I need to give it a null value. In this case, we're looking for is the proportion greater than 80%? So in the null hypothesis, I would set the true proportion P to 0.8, and my alternative will be greater. The randomization distribution here is simply that bootstrap distribution shifted so that the center is at the null value, the 80%, and we check to see, is the observed p hat very unusual compared to this distribution, or is it a usual value? In other words, what percent of the simulations yielded p hat greater than or equal to 0.8522? That happens to be a pretty low percentage of the simulations. With a low p-value as such, we would reject the null hypothesis and conclude that the true proportion is indeed greater than 80%. This agrees with the confidence intervals from earlier as well, because both of those confidence intervals laid above 80%. They did not include that null value. Finally, to complete the story, we can try this hypothesis test using a theoretical approach as well. And we want to make sure that when we're using a theoretical approach, our sample size condition or the success failure condition is checked, and we check that using the null value, and still we see that we have sufficiently large number of expected successes and failures to go ahead with the test. We calculate a z-score that happens to be pretty large, which yields a pretty small p-value, which means that we would reject the null hypothesis. Once I'm done with my analysis, all I need to make sure is that everything is included in my report. So let's take a look at my the knitter file here. I have a title for my report. I give some information about my data and why I'm interested in this. Then I read the data in. I also want to make sure that in my knitter document I am loading my inference function. And then in the inference section, I have the results from my theoretical and simulation-based inference. And we can see that all of the results we've seen before are included in my report. At this point, to complete my project, all I need to do is to add some narrative and some exploratory data analysis. Tell me about why you wanted to work with these data. What does the exploratory data analysis tell you about your research question? What do the inferential techniques tell you about your research question? And finally, a brief conclusion, and I'm done. I hope that this video has been useful for doing inference on one proportion using R. Thank you for watching.